Sweet. So mostly this is so we can all make sure we're seeing the same thing and saying the same thing, because not all of us came from the same teachers, not all of us learned these at the same school, some of us learned these in other languages. So just making sure we're all starting with the same place and not having a communication issue. So you might not need to write anything down from a couple of these pages. We're going to start by just kind of remembering some of these things. So we know the equal sign is equals to. The squiggly equal sign, that's about equal to or approximately equal to. It's an estimate. And the cross dot equals to is not equals to. We know our greater thans and our less thans. We're going to have our absolute values. And we're going to use our power of for exponents. I'm not saying this is like law or anything. It's just things we've seen and just making sure we're all in the same language communicating. Okay, so we've seen these things all before. We're going to deal a lot with absolute value and exponents today, because the way the book words the absolute value problems is unique. So we're going to practice several like it, because the book just feels out of left field. So we're going to practice those today. But we're also going to kind of use this as kind of a way to re-warm up our brains and revamp some things. So we're going to start by thinking about some inequalities, and oh snap, we're going to practice a little what? Oh my gosh. So we're going to look at some inequalities here, and we're going to decide which sign to use, if we're going to use less than or greater than or equals to. So if we're thinking about -7 and -4, what would go in this spot right here? Less than, greater than, or equals to? Less than. -7 is, in fact, less than -4. It's smaller. It is 100% an okay and valid thing to remember that crocodile eats the bigger number. I have a friend who's a literal rocket scientist, as in she works at Rolls-Royce in the aerospace engineering department. And I at one point asked her if she still thinks about the crocodile with inequalities, for which eats the bigger number. She went every single time. She's a literal rocket scientist. Okay? Just because we learn it in 1st, 2nd, or 3rd grade does not mean it's not a good tool. Alligator eats the bigger number. Okay, so let's go to the next one. Pi over 2 and 1.5. That one's a little trickier. I heard 2 different answers there. I love when that happens. It really does make me happy. What do we think? What is pi? 3.14, right? So it's a little bit more than 3. So a little bit more than 3 divided by 2, 1.5. When in doubt, multiply both sides by 2. You can do that. We can do that. It keeps everything the same. As long as I do it to both sides, it's the same. If I multiply both sides by 2, we'd see this to be pi and 3. Now is it easier to see? It's going to be a greater than. So if it helps, feel free to do an operation. As long as you do the same thing to both sides, as long as we use a positive number, it's not going to play games with stuff. Don't use negatives. But I just times by 2 to get these guys up here. It lets us kind of see that. So if we're not spotting it as fractions or decimals, multiply it by something to get rid of them. You could multiply by 10 if you wanted to. The bottom one's probably the trickiest one to do mentally. Square root of 225 and 15. Equal to. The square root of 225 is 15. So they're exactly equal to. So thinking through our relationships, being very intentional. If you wind up with pieces that are decimally and we're going, I think, multiply it. Try and get rid of denominators or divide to get rid of coefficients. Make the numbers be something that's a little bit easier to see. 100% valid. Okay. A little bit more cerebral on these ones. So if I wanted to write an inequality that says my x is negative, how could I do that? What could I say that x has to do if I know x is negative? Less than. What? 0. That just means x has to be negative. We're going to see that a lot. Just x being less than 0 just means it's negative. How could I write an inequality that says that z has to be between 4 and 2? Yes. Sorry, my brain took a second to process on it. 2 is less than z. I always cross my z, otherwise they start to look too much like 2's. Is less than 4. You could also do it for greater than z greater than 2, but that one makes my brain itch just a little bit. It's not wrong. It's just like saying in English versus Yoda. It's not wrong. It's just weird. So it's like, I like cats, or cats I like. Not wrong, but weird. So if we put them smallest to biggest, it tends to be more matching to like answer keys and stuff. This isn't wrong. It's just awkward to say. Makes my brain itch, but other than that, it's fine. If you want to do it as 2 separate inequalities, you could. Typically, we do as 1 inequality, smallest to biggest. I'm not super petty. I'm not going to stop most of the time. But that just lets us see it. So now we're going to think about, now that we remember that x less than 0 means that this piece has to be negative. So y greater than 0 means this piece has to be positive. And we're going to start to think about the relationships between these. So if I have this x times this y, is it going to be positive or negative? Negative, because a negative times a positive is always going to be negative. So it's going to be negative. What if we did x squared times y? It's going to be a positive because we're going to take that negative value and square it, which will turn it positive. So we'll have a positive times a positive, which is in fact positive. Woo. Now how about y minus x? It's going to be positive because we have our positive, and we're going to then subtract that negative. That double negative becomes a positive, so this will in fact be a positive. So sometimes we think them through very, very abstractly. This one always feels very, very abstract to me. Sometimes it'll be very, very specific with specific numbers. So our next bit we're going to look at is where it starts getting into some weird wording stuff, because we're going to think about some absolute values. So before we get into the weird wording, we're going to remember absolute values. So looking at these guys up here at the top, if I want us to simplify absolute value of negative 3 minus 4, what do we need to do first? More specific. Be more specific. Add what up? Add negative 3 minus 4. So we're going to have our absolute value of, what is negative 3 minus 4? Negative 7. What is the absolute value of negative 7? 7. So on this one, our order of operations is a little bit different. Over here, we treat the absolute value like a set of parentheses. So we have to do what's inside first. So on this one, we need to do our absolute values first and then add. So absolute value of 7, 7. Absolute value of negative 4, 4. 7 plus 4? 11. Boop. Okay, so now that we remember absolute values, these bottom ones are the way the book words these kinds of problems, and it's just kind of awkward and weird. It just, weird. So what the problems are going to say is they're going to say we want you to write the expression without the absolute value. So we're going to get an absolute value. That's going to be this guy here. So we have absolute value of 2 minus x, and we're going to get a restriction. So we'll have both pieces. Otherwise, we can't really do this. What that restriction is going to do is it's going to make the argument, the piece inside the absolute value, be either positive or negative. So we've got to figure out whether when x is less than 2, this piece inside the absolute value, 2 minus x, is that going to be positive or negative? So if x is smaller than 2, meaning x could be 1, x could be 0, x could be negative 10, would 2 minus that number be positive or negative? So think of a number smaller than 2. So maybe 1. 2 minus 1. Yeah, because then we could keep going. So 2 minus 0 would be 2, still positive. 2 minus negative 10, positive 12. So no matter what piece we pick from this restriction, this expression is going to be positive. So it's just like the 7. So it's exactly what it was here. And that's what this is saying. This is a direct snip from the book. It's just in the way. So when our argument, the bit in beside the absolute values, is positive, the expression is exactly what was in there, 2 minus x. So if the restriction makes the absolute value positive, just drop the absolute value bars. Hello, hello, thank you, thank you. All right. Then let's look at this next one. So let's figure out if the piece inside here is going to be positive or negative if x is less than 1/2. So when in doubt, pick a number that would make this true. If x is smaller than 1/2. Hi, hi.
My schedule changed, so I have you board period now instead of there.
Awesome. So if x is less than 1/2, you could use 0, you could use -1, you could use -2. Just sometimes it helps to have a number in your head. Because if x is less than 1/2, is this piece going to be positive or negative? So you can use 0. So if x is 0, what is this going to be? -1. If x is anything negative, this is going to be even smaller. So this is always going to be negative when x is less than 1/2, no matter what happens. So if what's inside the absolute value is negative, that's what this says here. If a is less than 0, inside the absolute value, then the way we write it without the absolute value bars is we need to take the opposite. So we're going to say the opposite of what's inside the absolute values are 2x minus 1. Well, we don't typically write things in parentheses still as an answer, so let's finish that out. How do I simplify that more? Distribute it, and we're going to get exactly our negative 2x plus 1, because we're going to distribute that minus sign through. You can 100% write it like that. I totally get it. It's the way I would write it too. If you're looking in the back of the book for solutions, a lot of times they will not put a negative number in front, so they'll write it as 1 minus 2x. 100% means the exact same thing. I would absolutely take both answers. I tend to write it this way just because I like to keep the x's in the front. The book tends to write it that way. They're exactly mean the same thing. We're going to practice this a couple more times just because it is awkward and weird and it feels like an overcomplication, because it is. So they like to do that and make things complicated sometimes for absolutely no reason. Yay, we love that. Okay, so I'm going to put up our next page, and at the same time I'm going to be rewriting part of the next page because they're way at the bottom for some reason. I don't know why. So I'm going to just rewrite these at the same time you guys are writing them down. So we're going to do our absolute value of a minus b if a is less than b. And we're going to do the absolute value of 3x if x is greater than 0. So we're going to do 2 more of these absolute values. I just want us to be able to practice these again. Because sometimes they're really, really specific. Sometimes they're really vague. Like this first one's really vague. So if a is less than b, we want to know if the absolute value of a minus b is going to be positive or negative. In situations like this, I do highly recommend pick some numbers. If we can't place it, or you can't spot it off the top of your head, assign values. Pick numbers. If a is less than b, maybe a is 2 and b is 3. Who knows? We're making it up. So if a is 2 and b is 3, what would a minus b be? -1. So if a is less than b, is a minus b going to be positive or negative? negative. So we don't have to test every single set of numbers. The relationship they give us is going to be on one side or the other. So we know this thing's going to be negative, which means if I want to write this without the absolute value bars, that's this guy up here. We're going to take what's inside the absolute value and put a negative sign out front. We're going to do the negative, or the opposite, of A minus B. But again, we don't like to leave negatives in parentheses all around like that. So we're going to distribute it out, and we're going to get the opposite of A plus B. 100%, I will take that answer. Oh, totally fine, 100%, no issues. If you're looking in the back of the book, more often than not, they will have this switched to be B minus A. They mean 100% the exact same thing, because it does not matter what order I add things in. 2 plus 3 is the exact same thing as 3 plus 2. Just like A plus B is the same thing as B plus A. So negative A plus B is the same thing as B plus negative A. Doesn't matter. We can switch them around. I tend to go here because I'm lazy and I don't want to do more work. All right, our last one of these absolute values, and then we'll get out of those. Absolute value of 3x if x is greater than 0 is 3x going to be positive or negative? Positive. So what is this expression going to be without the absolute value bars? 3x. If it's positive, it just is what it is. Okay? It's just a really bizarre way of wording things. And sometimes that's all that the book does, is they just word things in overcomplicated ways. Like, they do too much a lot of times. So, part of my job here is to be book translator. Okay, questions on our absolute value stuff. We're going to do a little bit of exponent stuff, and that'll be it. We're good. We got 20 more minutes. Perfection. I have 2 more slides for you. Well, this one and one more. Okay, so there's a lot of stuff up here. You have seen all these things before. The right-hand side are our exponent laws from like Algebra 1 days. Been a minute. So if there's anything you don't remember, write it down. If you remember all these things, you don't need to. On the left-hand side where it's got all these A's, I'm going to go through why negative exponents do what they do real quick, because I know a lot of times we have followed the orders and done the magic trick. And I'm going to remind us why the magic trick works of the negative exponent. But we have over here all of our laws are when we multiply the bases on exponential expressions, we can add those exponents. Powers of powers we multiply. Exponents can distribute to products or quotients. And the 2 different ways of simplifying quotients. With our chaos on the left, welcome to my brain, I'm going to rewrite these multiplying them out, just so we can see something. I'm going to start with a to the first. I'm going to write as just a. A to the second, that's the same thing as if we had a times a. A to the third, well, that's a times a times a. And a to the fourth, I don't know why I switched to green, there we go, blue, is our a times a times a times a, 4 a's. So as we go up, we're multiplying by a each time. So times a gives me another, times a gives me another. So when we go down, we're dividing by a. So I divide by a, one of them goes away. I divide by a, one of them goes away. I divide by a, one of them went away. So when we're getting down to that, to the 0 power, I am dividing it by a. So we have a divided by a. Both of those cancel out, we just get our 1. So that's why when it's raised to the 0 power, everything raised to a 0 power is just 1. And we can keep going with that. When we get to our negative 1, I'm doing the same thing. I'm taking that 1 from our 0, and I'm dividing it by a again. So when we have that negative exponent, it makes it flip upside down to the denominator of the fraction. And then again, when we do the square, I'm dividing by a again. So we get our 1 over a times a, or 1 over a squared. So I know you've seen that before. We've seen those negative exponents, but I just wanted to touch on again why it's doing what it does as opposed to just going negative makes it flip for reasons. Because I know sometimes it is just, I did the thing. I don't know what the thing was, but I did the thing. So just touching on it in case we've forgotten. But we're going to do a little bit of practice by, hello Aussians, a little bit of practice simplifying exponents. There we go. All of the words with all of the letters in them. So we're going to do 2, and then I will stop talking at you. Ha ha ha. Yay. So we've got negative 2/3 as a unit being raised to the 4th. As our first one. What I'm going to do is I'm going to use some of these exponent laws. I've got a fraction raised to a power. So I'm going to look at this guy. I've got a fraction raised to a power. So I'm going to bring that into both pieces here. So looking at this one, I'm going to take my negative 2/3 and I'm going to make this be negative 2 to the 4th over 3 to the 4th. I am keeping the parentheses around that negative 2. Whenever you have a negative value, especially with exponents, you've got to make sure things stay in parentheses. It makes a difference. Because I don't really know what negative 2/3 to the 4th is. Not off the top of my head. I don't know what 2/3 squared is off the top of my head. But I do know 2 to the 4th. What's 2 to the 4th? 16. So what's negative 2 to the 4th? 16. Same thing. What's 3 to the 4th? 81. So simply by splitting apart into 2 different pieces, it's a lot easier to figure out that without a calculator. Most of the time we are going to be able to use calculators. Occasionally we won't. I will always tell you in advance for if we ever have a quiz or a test where you aren't going to be able to use it for part of it. But we can do 4ths, especially with 2 and 3. All right, let's look at this right-hand one. I've got 2x cubed times 3x squared over 2x squared quantity cubed. What can we do here? I'm just going to put a fraction bar. Ooh, that was really far away. There we go. What can we do here? Say it louder. I was going to say, I love the thought of distributing. Is there any addition we need to distribute over? What operation is happening between absolutely every term there? Multiplication. So are those parentheses actually doing anything? These ones up here? Because it's 2 times x cubed times 3 times x squared. They're all times. It's all multiplying. So these parentheses aren't actually doing us any help. They're not hurting us, but they're not helping at all. It's all times. 2 times x cubed times 3 times x squared. So I can put those in whatever order makes my little heart happy. I don't have to keep them in that order. Just like 2 times 3 is the same thing as 3 times 2. 2x cubed times 3x squared is the exact same thing as 2 times 3 times x cubed times x squared. If there was a plus in there, that's when we would need to distribute. But since there's not any addition up there, it's just multiplication. Smash. What happens in our denominator when we try and get rid of parentheses? What is x squared cubed? X to the 6th. Good, we multiply those numbers together. 2 times 3 gives us 6. So now let's simplify that again. More steps. Oh my gosh. 2 times 3 gives us, I know I ask such hard questions sometimes. Oh my gosh. X cubed times x squared. X to the 5th. Good. Over x to the 6th. Can I simplify this more? Yep. What are we going to get when we simplify? 6 over x. Because the 5 x's on the top cancel out 5 of the x's in the bottom, and we are simplified. Woohoo! Okay? So it's all things you've seen. Tomorrow we're going to keep on going. We're going to get to some rational or some radicals, thinking about some square roots, those kind of vibes. Getting into quadratics next week. So what I'm going to do is I'm going to put up here, at the end of the day, I will always get the announcements page up, which should have the homeworks, what to do when, and what question numbers. Homework 1-1 I have due on Tuesday so that we for sure have 2 days because I want to make sure you guys have time to come in and ask questions if you have them. It's not very many question numbers. Several of them do have ABC like parts. So just to be warned, they're not super long. Like the ones we did today are very, very, very similar. Okay? So when you're doing homework, you can do it in your notebook if you really want to, but you're going to have to tear it out and turn it in. Or you can do it on loose leaf paper. I have piles of loose leaf paper if you want to borrow from me, totally fine. If you get it all the way done and you're happy with it and you want to turn it in early, I am happy to hold on to them for you. It's just got to be into me by Tuesday. Okay? Our first quiz is going to be next Thursday over section 1, which we talked about today, and section 2, which we're going to talk about on Monday, maybe Tuesday. Okay, so that's kind of the vibe. You guys have, oh, look at that, almost 10 minutes. What? Who's this with time? What? I'm shocked. So you guys can get started on it. You can work on stuff, look at it, take a peek at it. It's on page 14. The scan is up on the Canvas page, so if you do not have your physical book with you, which I highly recommend you leave those suckers at home, they weigh a freaking ton. There's a scan of those pages up. I also have several more copies of the book in here if you want to look at a physical book. Totally fine. Okay, so take a look at those. Give them a shot. There are some of those absolute value questions. It's the 26, 28, 30 are the ones that are the absolute values that are kind of weird.